Thank you for coming to the Mission Cloud webinar today on AWS Glue and avoiding rookie mistakes. We're very excited for Amber Runnels, one of our big data consultants here, to be giving this presentation. Next slide, Amber, where she's going to present on avoidable mistakes that she has seen while working with customers, while working with Glue herself, and while troubleshooting Glue when she was working with AWS itself in their troubleshooting department. If you have any questions during the chat, please add them to the chat window. I'll be monitoring that for all your questions, and we'll try to get them answered either on that particular slide if it's a clarification point, or later on at the end of the presentation when we talk about general questions. And we obviously, since they're on the chat window, we won't forget about it. We have some moderators on the back end to keep us honest as well. Next slide, Amber. So about Mission, I'm going to give the quick 30-second kind of overview. We're a premier AWS consulting partner. We're all in on AWS, so we only do AWS work. We help customers wherever they are on their cloud journey, whether they're at the very beginning just looking to understand what AWS can do for them, or whether they're advanced users where we can help them on multiple fronts, right? We are a certified AWS reseller with optimization, where we can help you with your bills and make sure that you're financially optimized on the cloud. We're a managed service provider where we can help maintain your infrastructure for you and let your workers get the critical things done and new services enacted. And we also have professional services. That's where Amber and I work from, where we're able to come in and do projects for your team, kind of as an extension of your team, building out anything in the data infrastructure that you're looking for. Our team is very capable on the data and analytics side, setting up all the infrastructure, as well as having data scientists to do machine learning. Next slide, Amber. So as a premier partner, Mission has to show mastery and received AWS competencies and delivery designations for a large number of services and industries. Mission brings these validated and verified expertise to your organization to really help them in their cloud journey. Here's just a sampling of them. We're in the process of getting several others, but we can help you anywhere that you are in your needs and whatever vertical you're working on. As an example, next slide, Amber, here's a few of the significant customers that we work with. We range from very large enterprise customers that you've probably heard of, like Moderna and the Celtics, to fast-growing startups like Fashion Nova and Simply Safe. And we're also working with many smaller startups as well that are really looking to get their footing in the cloud and take their business to the next level. With that, I will now turn it over to Amber so that she can tell you all about Glue and the rookie mistakes to avoid.
So today we will be discussing some common customer mistakes often made when using AWS Glue, as well as some pro tips that when implemented can help you to be successful. So we're going to be discussing mistakes in the areas of source data, crawlers, ETL jobs, and we're going to finish up with some Q&A for any questions that you might have on this specific content or Glue in general. So before we step into this content regarding mistakes, let's take a minute, step back, and understand why you should be using Glue. So to start off, what is Glue? Glue is a serverless managed ETL that offers a wide range of functionality and makes it very easy to discover, prepare, and combine data for analytics, ML, machine learning, or whatever need you have. If you've ever worked on-prem or worked on developing an ETL solution end-to-end, you know how long it can take to do this. So using Glue, you can get set up in even a few minutes and be ready to go with your ETL. So most customers use Glue to build data lakes and lake houses in a scalable solution. So they're able to process even petabytes of data in batch and real time using the underlying technology of Apache Spark. So using Glue, they've been able to migrate from these expensive traditional ETL solutions to a flexible and a cost-effective one. They've also been able to prepare data for ML. And one of the most popular aspects of Glue is being able to catalog data assets using the Glue data catalog and then feed this into other analytics services. So now that you know what Glue has to offer, the question is, how does it achieve this? These are just a few of the Glue services and features that are most commonly used And of course, there's many more, but we just don't have time to discuss them all. So to highlight just a few, you have the Glue data catalog that I just mentioned in the last slide. And this is a meta store that contains an index into your data stores. It defines the schema of the data, and it's used as a source and target for your ETL pipeline. It's just think of this as an Apache Hive metastore compatible catalog. So if you've ever used Hive, it's just your metastore. A Glue crawler, and this performs automatic data discovery on data stores and updates the data catalog with the schema of your data. There are Glue jobs. This is the logical process that performs the actual ETL, so it's the actual execution. And what it does is it runs a script that's either Python, PySpark, or Scala. There are also Glue streaming jobs. This is streaming ETL, so it's Spark structured streaming, if you're familiar with what that is. And it runs continuously, consuming data from sources like Kinesis data streams, Kafka, and also MSK. There's also the Glue workflow, which is the orchestration of your entire ETL pipeline, and it provides a graphical representation. So you can control what triggers certain events and then automate it end to end, including data discovery. There's Glue Studio, one of the newer services, and this is a simple visual interface you can use to interact with like semi-structured data, and you can create an ETL workflow and then run them on the underlying technology of Glue. Glue Data Brew, and this is has about 250 plus pre-built transformations that's more geared towards data scientists and data analysts, and it allows them to clean and normalize data to prepare it for things like analytics and machine learning. So those are just a few. There's many more, but we will be probably focusing just in this area for our conversation today. So let's get started and talk about why this conversation today. Why rookie mistakes? The Glue service recently has been addressing a lot of the pain points that customers have raised, and it's evolved so much, especially in the past couple of years. So just recently, if you've been keeping tabs on this, they released Glue 3.0. And all of this has led to an increase in adoption in the customer base. So I found that there are two groups that most Glue users usually fall into. There's Glue users who are new to ETL, and this is because Glue offers that click-through GUI to generate ETL scripts, like I mentioned, and even Glue Studio, that it just takes away the coding and the Spark aspect of Glue and allows you to interface in a GUI. The second group is those who are experienced on ETL and maybe Spark as well. So although you can use open source Spark on Glue, there's a few caveats that are important to know to be successful when using Glue. So let's jump into the first area, that of source data. The first mistake is using incorrect file formats. And the symptoms you're going to see for this are Spark executors running out of memory, crawlers inferring the schema incorrectly, and just slow performance across your ETL pipeline. So how can you overcome this rookie mistake? The pro tip here is to make sure that your file is splittable, or if it's not, the partition has to be able to fit into executor memory. So those of you without a Spark background, what this is referring to is a Spark partition, which is a logical split of the input data that's distributed to the executors, and this is what enables parallelization. So maybe if you're more familiar with the data engineering side of things, this is what you're manipulating when you perform a repartition or a coalesce operation. So some file type examples that are splittable are CSV, Parquet, ORC, and some non-splittable types are XML and JSON. In addition to the file types, you also need to consider the codec types. So this is compression, decompression types. Some codec types that are splittable are bzip2, snappy, and gzip. And this is kind of like a little bit of a tricky thing, but snappy and gzip are only splittable if the blocks inside are splittable. So if you combine it with Parquet. So Parquet with gzip and Parquet with snappy are splittable, but in general, snappy and gzip are not splittable. And also LZO, only if it's indexed. So there's a couple of caveats with the codec types that are important to check out. You're also going to want to consider converting to Parquet or another columnar format whenever possible. So if you do so, you're going to see huge gains in performance and efficiency. And using Parquet is even being seen 100 times performance gain over CSV. Lastly, you're going to want to consider schema evolution when choosing a file format, since there are certain operations that are supported with certain file types. Common scenario that's frequently encountered is using a CSV file format, and then you're trying to add or remove columns in the middle of the table. So if you know that that might happen with your data set, make sure you choose a file format that supports this type of operation, like Parquet, for example. So the next mistake is not verifying the quality of your data. Some symptoms of this mistake might be the crawler misinterpreting the data. You'll see data in wrong columns after being processed by ETL. Basically, it's all sorts of unexpected behavior. So it's important to note that Glue will have issues if your file is not UTF-8 encoded. What's the pro tip here? The best way to deal with this is to explore the quality of the data using Glue Data Brew. So this is one of those newer services that I mentioned that lets you examine what your data looks like in an interactive session. You're also going to want to incorporate data cleansing and verification into your ETL process to handle bad records if you're not already doing so. A common customer scenario might be you're receiving files from a third party, and intermittently, perhaps those files contain non-UTF-8 characters. A helpful tip to deal with this is if the data is located in S3, you can use Amazon Athena to identify the problematic files for further investigation using that $path functionality, which is a pseudo column. And then using this method, you can identify the file that's causing the issue, and then you can take those steps to rectify it, and hopefully you can build that into your pipeline. So this is an example here of what the Glue Data Brew console looks like when you're verifying the quality of the data. So if you notice there, it has that column that shows data quality, and you can identify how many values are valid, invalid, or missing, so you're aware of the problem. The next mistake is having Glue operate over many small files. Symptoms of this will be your driver running out of memory, jobs and tasks failing, and just slow jobs in general. Some background on this is that during the creation of a dynamic frame or a data frame, Spark will create a list in memory of all the files to be included. And then once it's completed, it's going to create the object. So if there's too many files, the driver is going to encounter out of memory errors during the listing of those files. Or you might see in your job logs that the job just spends all the time listing the files and then a very short amount of time doing the actual execution. Once the driver has those files, it's going to send them to the executors to perform this task. So once again, if you have so many files, then there's another potential pitfall here that the driver might encounter an out of memory issue when it's receiving data regarding those tasks from the executor. So the pro tip for overcoming this rookie mistake is to consider scaling up your worker type to G1X or G2X, which are recommended for memory intensive jobs. And we're going to discuss what exactly this means more in depth later, but for now, let's just keep that in mind. You can also use the use S3 list implementation feature. And what this does is that Glue's not going to cache all the list of the files in memory at once. Instead, it's going to batch it. So it will lazily load those S3 objects. And as a result, the driver will be less likely to run out of memory. And this is AWS best practice and should be used in conjunction with job bookmarks. You can also use a grouping option for reading many small files, which is automatically enabled in dynamic frames when you use a large input data set like 50,000 plus. So what this grouping option does is it coalesces the files together, and then the tasks are performed on the entire group instead of a single file. So if you enable this, it can alleviate some memory issues in the driver because there's going to be less tasks to maintain because of the grouping. So that wraps up the source data conversation. And the next area we're going to talk about is Glue crawlers, so exploring these data sets. The first mistake that customers often make on crawlers is not crawling a subset of the data, which will result in long-running crawlers. And this is because the Glue crawler will look for new or changed files in your tables or your data stores, and it will perform this data discovery to see what's changed. So to overcome this, first off, you want to make sure that you've configured your crawlers to perform incremental crawls with that option, crawl new folders only. So keep in mind, you're going to want to enable this once you've already performed a full crawl on the data. You also want to make sure that you're not crawling unnecessary folders. So to do this, you can use those include and exclude patterns to identify the data to be crawled. You can also use several crawlers to point at a subset of the data rather than like using one huge crawler to point to the parent location. So it's always better to have smaller, multiple crawlers instead of one humongous crawler. Lastly, another tip that can help to significantly reduce the time of the crawl is using the sample size configuration. So you can specify the number of files that a crawler is going to randomly check to verify the schema rather than checking every single file. So there's a small warning here in that it's only a good choice to use this configuration if you don't expect your schema to change, but it's also going to be a huge help in shortening the time of your crawl. The next mistake is not configuring your crawlers correctly. So this is closely related to the last one, but some symptoms here might be like one of the most common one is the crawler creating too many tables. So maybe based off of S3 data locations, you're expecting to have 5 tables. You run your crawler, and instead what happened? 35 tables were created. I'm pretty sure most of us have been here when using the crawler. So what happened here? There's a feature for the crawler called combined compatible schemas, and it can be enabled using create a single schema for each S3 path. That's the checkbox that you'll see in the crawler configuration. So the crawler, what it does is it considers both data compatibility and schema similarity. And so when you use this option, it's going to group the compatible schemas into a single table across all the S3 objects under that path. And as long as the schema is similar enough, it's going to combine them into one table. So let's say you enable that setting and you run your crawler and it's still creating more tables than you expect. What do you do next? You're going to need to go and investigate the underlying data and see why it's different. So a helpful hint here would be to look at the table definition in your Glue data catalog, and then also check out that $path functionality in Athena to identify the files that table is referencing. Lastly, you can also specify the table definition under the grouping section. So using that path there, I have specified on the slide. If you wanted to have a sales table, you could set the table level to 3, so you can even further define how the tables are defined on the underlying data. So this grouping section is an important configuration that's often missed on the crawler because it's kind of, it's at the end of the crawler configuration at the output section and a little drop down section. So make sure you enable this functionality if you're experiencing this issue. So now that we've configured our crawler correctly, we're ready to go to our Glue jobs. The first mistake on Glue jobs is not using dynamic frames correctly, or maybe not using dynamic frames at all, especially if you're used to using open source Spark and you just lifted that into and shifted it into Glue, you might be using data frames entirely. So some symptoms of this might be poor performance. And just really in general, you're missing out on a lot of the functionality that Glue has to offer because dynamic frames is specific to the Glue service. So if you're not familiar with Spark, the way this works is that data frames require a schema to be specified. So what Spark does is it performs 2 passes over the data. One to infer the schema and the second to load the data. A dynamic frame, on the other hand, can infer the schema on the fly. So right away you can begin that transformation. It's also easier to deal with unexpected changes to the data, such as like new fields, inconsistent types. There's a setting called resolve choice that will help you to fix a lot of issues in your ETL pipeline in regards to data types. So there's just some of the few features of a dynamic frame. There's so much more. But there are some operations that might still require the use of a data frame. So what do you do about that? You can easily convert a dynamic frame to a data frame and vice versa using the toDF functionality. So if you're going to be using both dynamic frames and data frames in a Glue job, it's important to keep this in mind. You want to start with a dynamic frame and only convert to a data frame if you need more complex methods that perhaps aren't supported by dynamic frames. So what are some of these complex methods? It might be something like you're trying to do an expensive join across a data set, and you could benefit from using something like the Spark Catalyst Optimizer, if you're familiar with what that is. The Spark Catalyst Optimizer is unfortunately not supported currently by dynamic frames. So when you're doing these transformations between dynamic frames and data frames, try to avoid converting them back and forth excessively because it's going to consume a lot of memory. So start with a dynamic frame. If you need to convert to a data frame, do it. And then in the final write, finish off with the dynamic frame when you are writing to your target data store. So the next mistake that's commonly encountered is not using job bookmarks correctly. So if you haven't used job bookmarks before, they allow Glue to keep track of the data that's been processed in each run of the ETL job from S3 or JDBC data sources. Using a bookmark, you can do things like rewind a job and like reprocess a subset of the data. Or if you're in a backfilling type scenario, you can reset the bookmark entirely. So to make sure you are using a job bookmark correctly, you need to ensure that your job contains the settings that I've listed here on the slide. And this is often missed if you're writing your own scripts because these settings are not used in open source Spark. So if you don't have these settings enabled, you're going to want to check that because you might be experiencing something like reprocessing of files. So most customers seem to have confusion I found over the transformation context parameter. And if you're confused how to correctly implement this, just take a look at one of the Glue generated scripts to see how this should be set up. Also, bookmarks in S3 and JDBC behave differently. So for JDBC, it will only process new rows, but not updated rows. In S3, it uses the last modified time of the object. It's important to understand what makes a JDBC data source different from an S3 data source if you're using one. So the slide here, I've listed another example, that the table's primary keys need to be in sequential order. So take some time to review the specifics of using JDBC data sources with job bookmarks if you're implementing one of those. Lastly, you will want to verify in your Glue job logs that the bookmark is actually working and skipping files like the log snippet here shows. So take some time to go through your job logs and make sure that that the job bookmark is actually working and you can see that functionality in your logs. And since there's so much confusion around the transformation context, I wanted to include an extra slide around it. And what this is it's a unique identifier for the ETL operator instance to help identify the state information within a job bookmark. So what's actually happening, what files have been processed. So a common customer scenario is to process multiple tables data in a single ETL job using a for loop. The problem with this is that the transformation context needs to be unique for each data store in order to be able to track those files that have been processed. So here's a super pro tip. To ensure the transformation context is unique across the data source, within that for loop, parameterize it, and then you can append a unique value, such as the table name to it. And then when you use this method, your job bookmark will function correctly because it will be unique to the data store. And then you can still loop through your data stores as before, and you don't really have to refactor the code. Another mistake commonly made by Glue users in ETL jobs is not partitioning correctly. So for this, the symptom may be very widespread. It will be poor performance across your entire data infrastructure. So there's a warning here that's sometimes missed. If you're using the default Glue generated scripts that you made from the console, it's not going to partition when you're writing the output. So a lot of customers will read in from partition data, and then they'll expect that in the final write, when in their target data source, that it will also be partitioned, but it's not. So you need to make sure that you implement this in your job. So what's the pro tip? Make sure that you're partitioning at the job output. So then when you do this, you can take advantage of performance optimizations that occur at the actual partition level, things like partition pruning. So here I've included a code example of how you can do that. You also want to make sure that you're taking advantage of a push-down predicate within Glue. So unlike filter transformations that may be on the data engineering side, perhaps you're more comfortable with using a filter transformation. The push-down predicate allows you to filter on the partitions, but you don't have to list and read all the files in your data set. And also push-down predicates are evaluated even before S3 list implementation that I mentioned. So I've included a code example here of how you can easily use push-down predicates within Glue. The next mistake is using incorrect worker types for your jobs. So you may see jobs failing with out-of-memory errors, or you're just losing executors. So going back to the earlier point about the Spark partition fitting into memory, in the discussion, if it doesn't fit into that executor, you're going to want to scale up your worker. So the specs of the workers are listed here, but keep in mind that, for instance, if you're considering a G1X worker, not all of the memory that's allocated is actually usable in terms of going directly to the executor. So some of this memory is used for features like the executor memory overhead, if you're familiar with what that does in Spark. So the partition needs to be able to fit into 10 gigabytes, not the 16 gigabytes. You're not going to get the entire 16 gigabytes. So make sure when you're considering your data set that you pick the right worker type. Also, if you create a Glue job through the console, the default for Glue 2.0 is 10 workers that are type G1X. So there's an opportunity there to right-size your job for cost savings, or maybe even scale up your number of workers so that your job will be more performant. So next, you might ask, how do I know if I can scale down the size of the workers, or if I need to scale up the size of the workers? You can do that if you're monitoring your Glue job, which is our next and final rookie mistake. So if you're not monitoring your Glue jobs, you might have an issue with runaway jobs, with failed jobs, and just you're not going to have Glue be as optimal as possible in terms of performance and cost. So what's the pro tip here? You want to enable Glue metrics on your job. Even if it's temporary, you can use this as a benchmark later on for things like looking at performance degradation. Via Glue Studio, you can have that single pane to monitor your jobs, and then you can compare performance. Additionally, you're going to want to enable continuous logging so that you can get that logging real time pushed to CloudWatch, and it does this on a 5-minute interval. And if you're a Spark user, enable the Spark UI for your job, and then you'll be able to see what's actually happening on the underlying data set, what operations and transformations are happening. Lastly, and probably the most important, is that you want to set the job timeout. So too many customers, they leave the default value for their Glue job, which is 48 hours. And then one of their job run ends up running for the entire 48 hours. And they get a massive bill that's like a runaway job. So make sure that you know the upper bound of how long your job should take to avoid a huge bill if things go wrong. So this here is a screenshot of what the Glue Studio provides for monitoring. So you can kind of see like a holistic view of your jobs. And then also in each job run, you can see if you're not using all the resources you have allocated, or maybe you are using all of them and you need to possibly scale up for your job. That red mark you see there, it makes it very clear. It's 50% usage for the memory profile for your Glue workers. So if you are, very underutilizing your workers, you can go ahead and scale down the number of workers, or maybe even the worker type. So that wraps up the content for today's discussion. So with that, I'm going to go ahead and turn it over to Ryan.
Amber, thank you very much for that detailed set of pro tips that everyone can use, and super valuable information. One of the questions was about sharing the presentation. The recording will be available after this. We'll send out a link and whatnot so that you have that and can look at the code samples and snippets that Amber was sharing. Really appreciate everyone coming today. We're going to put up a quick poll question right now. If you've got questions about Glue, we have a free 60-minute data assessment. So if you're looking for help or you want to have additional, more in-depth questions on Glue, you can select one of the, you can select yes, and then our team will get back to you and work with you some on, whether it's Glue or just your data lake in general. It'll give you a chance to talk with a data architect on our team. As an added bonus today, if you guys are looking for managed services, we, if you do managed services through Mission, you can get a 25% discount on your bill for the professional services, which would have, like our team come in and help you build out the data infrastructure. I see, people have answered the poll. We'll give it another, about 20 seconds before we close it and get into the rest of the questions. Okay, awesome. We're almost at 50%, which is great. So Amber, cute dog background there. Not sure if that was supposed to be seen.
I don't know what's going on with the control panel. Webinar keeps switching it.
But anyway, the first question out of the gate here is whether or not you have tried Glue 3.0. As we saw, it became GA, I think, Tuesday? So yesterday.
Mm-hmm. Yes, I was very excited about Glue 3.0. I've been playing around with it and reading the releases, but I have not specifically implemented it on a customer project yet.
Awesome, thank you. There was another question that I saw. When does somebody decide when to use Glue versus Glue Studio versus Glue Data Brew?
Yeah, that's a very good question. So both, I think there's a lot of probably confusion around Glue Studio and Glue Data Brew because they both are kind of like visual GUI interfaces. So the way that you kind of think about this is Glue Studio, think of it more being towards like job oriented. So it's designed to be used by data engineers, but maybe they're not so familiar with Spark. And it gives you like this monitor for the Glue jobs like I showed in the screenshot. But this is really designed for PySpark. It creates a PySpark job, and it gives you complete control of your code. So you can be able to go and look at your Glue jobs, you create it in the visual interface, and then go to the Glue job, and then you can modify it as you like. Whereas Glue Data Brew, think of it more as being designed to be used by a data scientist, more for like machine learning. So it has a lot more complex transformations that are not offered by Glue Studio. And you don't have complete control over the code. What you get instead is a recipe that you can share. So this is more for a data scientist type or business analyst type role. And then lastly, Glue is kind of the underlying infrastructure for all of the jobs, but this is more geared towards maybe if you're a Spark user and you want complete control over what's happening. So there is an option to have Glue generate the jobs as well for you, but you can go in and manipulate it yourself if you would like that to have that level of control.
Awesome. Great to understand the difference between those services. The next question we have, what metrics should we set alarms on to scale up and down those number of workers?
So there are driver-specific metrics, and then there are also executor-specific metrics. So it's important to have that distinction because then you can know where the problem is and then address it. So some of the metrics that you'll want to watch for these are JVM heap usage. So Glue is a very memory-hungry service, so you're going to want to watch for the memory in case of any like out of memory type errors. And this is also what's going to indicate if you can scale down or scale up. Also, disk space usage, there's a metric for that as well, because the way that Spark works is if it runs out of memory, it will start spilling to disk. So you're going to want to watch the disk space as well. Additionally, CPU system load. So most Spark jobs, it's the issue is usually around memory as the primary resource, but occasionally, depending on the operations that you're performing in your Glue job, it could be an issue about CPU as well. So check that as well, and just see if your workers are not overloaded at the CPU or like the system level. And then there's also like you can monitor things like how many bytes you're reading in from the file system. So in case you have like a job that's run away and it's reading tons of information, you can set a metric for that as well. So the Glue documentation has like a nice like table that helps you to kind of identify the metrics and then how you can use these to diagnose the issues within your Glue infrastructure.
Awesome. So here's a question that you may have to read if I don't do it justice. There's a question on any pro tips on partitioning tables using a date column, right? Do you see any significant query performance improvements when you partition, one date style versus a different date style?
Yes, that's a very good question. And actually, I had included that in my slide, but for time reasons, I didn't want to kind of overload on information, but that was actually one of my pro tips as well, was the time-based partitioning strategy. So that's one of the largest things you want to do because you want to group together the data that's being updated so that like if you're crawling or performing data discovery, it doesn't have to recrawl. It's all in one place, all in one partition. So around the specifics around like date-based partitioning, you want to kind of have a balance of being able to like make your partitioning as fine-grained as possible, but also not have so many partitions that your job will spend all of its time listing the partitions and then inside having a small amount of files. So I would say, depending on how much data is inside each one of those partitions, you're probably most like enterprise level or just customers with very large data sets will fine-grain all the way down to at least the day, maybe even the hour. So it depends on how many files are in there and then how many partitions you have before the date level. So try to avoid millions of files, but yes, use time-based partitioning. Sorry, try to avoid millions of partitions, but yes, absolutely implement time-based partitioning. So I'm not sure if that exactly answered your question, but it's kind of a delicate balance there. So try to go at least for the day level if you have enough files.
Awesome. You've got another one on, do you have any tips for best practices of migrating Spark jobs from Cloudera clusters to Glue?
In terms of how I would probably do that, so like I mentioned, Glue does support open source Spark. So if you are using just general Spark, that can be ported directly into Glue. So that being said, what I would probably do if I was migrating these jobs in is I would pull this up into a Glue dev endpoint and pull my code in and just run through everything and try to benchmark performance. And then once I use the open source Spark, then I would try to look for optimization strategies that are Glue specific to be able to compare performance. So things like using dynamic frames, using S3 list implementation, using job bookmarks, using all those pro tips that I mentioned in today's discussion to be able to compare performance and see how Glue can optimize even just a typical Spark workload. So I hope that answers your question, but let me know if there's a follow-up on anything specific.
Awesome. Yeah, there's another question that I think I understand, where they're basically trying to understand whether you can use Glue instead of Uzi. I'm not sure if you've ever used Uzi or not.
Yeah, it's going to, I guess I would probably want some more details on what specifically you're doing. So Glue has a lot of different functionality they can use to manipulate data. So I would say let's talk more about what you're specifically doing in Oozie, and we can see if Glue is the right fit for that. Yeah, because I've seen a lot of like complex implementations using something like Glue as kind of like the serverless ETL, but I guess it would just depend on what you're doing. So I would say let's set up that free 60-minute assessment, and we can talk about whether Glue would make this need.
Awesome. Yeah, it doesn't look like any other questions. Oh, actually, hold on. There's a job scheduling. I guess so job scheduling and Glue, I guess, are there any true pro tips around job scheduling? I think that goes to their Oozie question.
Yes. So what I mentioned around the Glue workflow, you can use that as an orchestration engine in order to kick off your jobs, and then you can create like different triggers and different criteria for your workflow. And one of the things that's really awesome about Glue is like the way I like to think about it is it's kind of like the Lambda of the data world. So you can have many different like you can have concurrent executions, and they're all taking place. They're taking place on Spark clusters that are on the control side of the service. So you can run as many jobs as you want to run. And it's not going to affect like you don't have to do resource planning on a cluster or something like that if you were running on, say, EMR, where you'd have to go in and do change the capacity scheduler and start working on resource planning. Glue is going to be independent, and so you can just do concurrent executions of that, and you can design the framework within the Glue workflow. And even if you have something that's maybe like an extremely complicated workflow, you can plug that in with other orchestration engines like Airflow or step functions and something like that to be able to have like a complete serverless infrastructure.
Awesome. I'm not sure. I'll leave one last minute if anyone has any additional questions, but otherwise, thank you everyone for attending. I hope you found everything insightful. Lots of great content that Amber was sharing. So appreciate your time. Appreciate your time as well, Amber, in putting this all together. And then, like I said, I'll give another minute if anyone has any additional questions. I guess I didn't look in chat. Okay, great. Thank you, everyone. Have a great rest of your day. And as I said, the presentation will be available, the recording of it, so that you guys can go back and reference any pieces that you want to see.
Thanks so much, everyone.